The wireless telegraph came into being in 1901 when Marconi sent Morse code messages across the Atlantic Ocean with a spark transmitter. This proved to be of great assistance in the transmission of information from one place to another, but could not be used for the transmission of speech or music. In 1906, human voice was transmitted for the first time. Radio broadcasting of speech and music developed rapidly during the 1920s. Radio is now playing an ever increasing role in human life on land, on sea, and in the air. It is being used not only for communication of news, entertainment, and messages from one place to place, but also plays an important role in navigation. The basic principle and working of a radio will be outlined below. We need transmitting station from where information is sent out through the antenna into atmosphere. At the other end, people have receiving equipment connected to antenna which receives this information. When we send a parcel to someone, it is taken away by a postman who rushes it to its address through postal service and electronic communication by radio. High frequency radio waves play the role of postman, and the information parcel is hidden in these by a process known as modulation. At the receiving end, container receives the full package of high frequencies radio waves plus the information, and the radio circuit separates the information by a process known as demodulation. Radio transmitter use alternating current of frequencies ranging from 30 to 30 called radio frequencies. The frequency of audible sound varies from 20 Hz to 20 kHz, and sound waves travel with a speed of about 340 meters per second only. When someone speaks into the microphone at the radio station, sound waves are converted into electrical fluctuations of current coming from the microphone. This is superimposed on the high frequency alternating current passing in the transmitter antenna, with the result that the amplitude of the radio waves also fluctuates correspondingly. The sound or message is therefore carried through space by these fluctuating radio waves, which are known as modulated carrier waves. When the modulated carrier waves meet a receiving aerial, which is a piece of metal wire at some distance from the broadcasting radio station, they generate fluctuating alternating current in it. An earphone is connected to the receiving aerial through a suitable rectifier. The rectifier converts the alternating current generated by the radio waves into direct current. This direct current fluctuates in harmony with the changing amplitude of the radio waves, thus causing the earphone to reproduce the sound. There are usually a number of radio stations in an area broadcasting their programs at the same time. However, each broadcasting station produces radio waves of a different frequency. All these waves generate alternating currents of their own frequencies on the receiving aerial of a given radio set. We can select one particular frequency from this mixture by using a tuning circuit which responds to the desired frequency and ignores all other frequencies. The better the quality of the radio and its tuning circuit, the less it is affected by the waves from other radio stations using similar frequencies. In a television network, images of objects, whether moving or stationary, are transmitted along with sound over electromagnetic carrier waves from one place and are received at another distant place. Television technology has now been standardized and finds an increasing use in the realm of entertainment, education, industry, and space exploration. For picture transmission, a TV camera is focused on the object or the scene to be televised. The convex lens of the camera produces an image of the object seen on a thin photosensitive plate called the mosaic in the camera tube. The material of the mosaic screen has the ability to emit electrons when light strikes it. When where the light is strong, more electrons are given off, making the material positive. At that location, a beam of electrons from an electron gun in the camera tube is made to scan the rear surface of the mosaic screen along successive horizontal lines on it. This is achieved by means of a special magnetic deflection system incorporated in the camera tube. When the beam hits an area with high positive charge, few of the negative electrons are repelled. When there is only a little positive charge, more of the electrons are repelled. These electrons are collected and converted into voltage pulses. This is how a picture is converted into voltage pulses called video signals. Sound is also converted into electric pulses known as audio signals. Amplified video and audio signals are used to modulate very high frequency carrier signals before being radiated through an antenna in the form of electromagnetic waves. When the modulated electromagnetic waves sent by a TV station strike the antenna of the TV set, they induce fluctuating alternating currents in it. The electronic circuits in the TV set separate the audio and video signal, which are then amplified. The audio signals are sent to the loudspeaker, which changes them back into sound waves. Video signals are sent to the electron gun of the picture tube to produce a weak electron beam of darker parts and a stronger beam for brighter parts of the television picture. The screen of the picture tube is coated with a fluorescent material which emits light when electrons hit it. In this way, we can see the picture on the TV set along with the sound. All sound produce vibrations in a material medium as explained in chapter 12. If these vibrations are recorded on some sort of disc or tape, one can reproduce at any time the original sound from the impression made on the disc or tape during the recording process.